Well, hi, good morning. Thanks for joining me in the shop here, sharing in my frustration as I kind of struggle with this radio and doing the alignment work on it. So one of the things I haven't done yet is really gone through the schematic carefully. Maybe that's part of why I'm struggling a little bit. Yeah, I should have gone through the schematic a little earlier. So I'm going to start off by just reviewing the schematic for the radio and see if there isn't some hints. One of the things I really want to figure out is what is going on with this overly complicated tuning capacitor with 6 sections and 6 trimmers on it. I'm just curious about how all that's supposed to work. So let's jump to the schematic here, and I'm going to struggle with that. Okay, here we are. Let's go straight to that question of the tuning capacitors. And where are they? So there should be one section affecting the oscillator, and it'd be basically a section going with each of these coils, or a section going with each set of these coils. 3 sections, 3 sets. So often they draw the tuning capacitor differently from other capacitors to make it stand out. I don't see that here. The other thing that's commonly done is sometimes they will draw, like for instance this one has what looks like an arrow through it, and this one looks like a nail. That looks like a nail head on it. You can see here nail head, arrow, 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 arrow. So that's telling me something. The diagram in here is really hard to look at. The numbering scheme, well, you'd think they would number these things too in such a way that you can relate them. So, for instance, of one of the six sets of blades, there's one trimmer that goes with it. Well, there's one small set of blades that goes with it, so it appears. So you think those 3 items would be somehow close together, like something like that, like the 3 of them there. In fact, these two are just in parallel. Now that looks like the nail, and this looks like the arrow. So that says C14. Let's look on the list and see how it describes C14. A trimmer. So the 2 to 10 picofarad trimmer on the gang. Trimmer. So to me, that's one of the screw capacitors. That kind of trimmer. And 14, where did 14 go? I picked 14 only because I could see the number very clearly. There it is. With a nail. Trimmer, T, trimmer. Now what about this? This looks like C8, C9. What is C9? C9. So 397 picofarad gang. So I'm guessing this is the maximum capacity, and I'm not bothering to write the minimum. It looks like 397, looks like the same thing here. There should be 3 of these then. 397, 397, 397, way over here. Gang. So here they put the trimmer with the gang. Let's find these. C29 and C30. C29 and C30. There they are. C29, C30. C30 is a T. C29 is an arrow. C29 is the bigger capacitor. Isn't that right? C29, C29, yeah, 397. So we should find 3 sets of these. Be the gang and its trimmer. The gang and its trimmer. And then this is C1. Here's C1. C3 would appear to be the trimmer for C1. Look, they're right across each other. C1 and 3. C1, C3, trimmer. 2 to 10. Okay. Now, the small plates that tune, those would be with a very, they might be like, they've shown the big ones with just a fixed amount, although it's not fixed. Oh, there we are, fixed amount on the gang. So this 28 picofarad must be the small plates. And where do they show that? C1, C2, C3. So the side plates are not, the small set of plates is not connected the same way the big one is. Okay, let's try this on another one now. We'll go down. So here's, well, there's the 28. There's the trimmer, and this must be the gang part. So they haven't really numbered them together as such. So the numbering's not going to help here. So 397, 2 to 10 on the screw trimmer, 28 on the little guy beside it. C5. Can we find C5? C5 is a little guy. C4. That's probably 5 there. Looks like it's shown with an arrow. C3 is shown with an arrow. So the arrows are the big tuning capacitor. Are they? Here's C9 with an arrow. C9. Does that fit in there? C9, yeah. C9. So all the arrows. So for instance, here's, yeah, we already did this one. Find another one. Find another one with an arrow. That's got an arrow. 39, yeah. 39 or 29. 29, I think. 29. Yeah, there it is. And it's trimmer, C30, right there. And then there's some side plates. The 2 to 10, there they are. Oh, no, not 2 to 10. 28 was the value. So I look for the word gang. Here's 28 here. Well, 24. 24, I'm not sure I'm following this quite correctly anymore. There's 24. 24 is related to 29. Oh, they're attached to different coils. But so 24 must have a trimmer. Let's go back down here again. 24. 24 is the 28 picofarad gang, and then it has its own trimmer, which is probably 25. 24. Well, that's 25. I don't know. I'm going around in circles. That's not 24. This is 24. This is 20 something else. Darn numbers on here. Okay, so did I get it right now? The big sets of plates are tuning one part of the circuit, while the small set is tuning something else. That's what it looks like over here. Let's look at the oscillator one. Yeah, that's probably this one. So C1 and C3 would be oscillator. They would be, if they're oscillator, they're at the front of the radio. This is underneath the chassis. They don't tell you. They don't give a hint. No hints anywhere. Negative temperature coefficient. Oop, watch out for that one. What are eliminated? Just let my eye wander through here for a sec. Coils, tubes and lamp switches. Just looking to see if there isn't a hint here that I've overlooked on things. Loop antenna. just kind of listing them. Oh, here they are, L numbers here. Well, how is this going to help the situation? Well, I have a notion now of how that capacitor is working. And that would mean that each of the six plated sections has its own trimmer. And it could be, yeah, I don't know. It could be, I don't know. Exactly. Very good. Well, it's going to be fine. I really haven't even studied the schematic very much yet. So we got the grid here on the first RF amplifier tube. Nothing terribly special going on. These are these tuned circuits. A million trimmers and slugs and stuff. 2 IFs. That's just, yeah, maybe I have looked through this. I've looked through it a bit. Showing the big filter capacitor up there. Yeah, there's nothing more for me to really gain from looking at this any further. But I think I got the big tuning capacitor sort of thought out. Maybe we carry on with the alignment, it'll become more apparent. Okay, so we're ready to go here on step number 5, which is shortwave band, 6 megahertz, cores of the RF coils. So I think it just suddenly has come clear to me. I've been looking for the word antenna in here, kind of in the back of my mind the whole time. They're not using the word antenna. They're calling the antenna coils RF coils. So there's 2 sets of RF coils, if you ask the engineer who wrote this. And no antenna coils, so stop looking for them, Jim. So when I read cores of RF coils, I think what they really mean is the intermediate stage coil and the antenna coils. The intermediate stage coils are here and the antenna coils are on the back. Access is through the back. I think I may have a grip on this finally. Yeah. So, you know, I've learned that when you do this stuff in a complicated radio, you know, multiband radio, chances are first time you go through the alignment, it's just an eye opener, not much more. So my eyes are wide open here. So that's it. So we're ready to do this now. I've got the radio set on shortwave, tuned. Let's just check the tuning on it here. Make sure it's tuned to 6. Right there. 6 megahertz. Okay. Make sure the signal generator is in agreement. Oh, it is. And neither of these are oscillators. So the fact that I'm not hearing the signal generator right now means the oscillator's a touch off here. This is the one I think I avoided tuning because I thought it was so close. Let's see if we can find the signal here. Where is it? No, it might help if I hooked up the signal generator to the antenna. Still on 6. That's funny. What the heck's going on there? Okay. That's good. What happens right here? And then it stops. Some kind of oscillation in there. Oh my gosh. Okay, so here's 6. Let's go back and look at where 6 is coming in. A little off. Now, why can't I bring that back using the core of the oscillator coil? I'd be doing this out of order at this point. Well, you know, I'm still on the first time through, so it's all about making every possible mistake this time through. Shortwave oscillator. Much louder, right, than before. So that in itself could be bringing a couple things into alignment. That we're going to do this the whole time. Maybe now we're going to do that. I don't know. And is that really still 6? And the answer is yes, right on 6. 6 there, 6 there, 6, 6 everywhere. Let's do the thing. So I've done, okay, RF trimmers, we're ready now. Cores of RF coils. Cores. Yeah, I just say anything and do whatever I want after that. I'm gonna watch the excitement over here as I introduce this tool. Try to get back there. You can't see it, but I'm watching the meter. So that's what I'm doing. I'm sticking that way back in there. Make that meter come up. Okay, here we go. Well, it's definitely down that way. Down. Very clear peak. What happened to it? For some reason the peak kind of went away. Where'd it go? Is still tuning itself. Meter. The meter act up. Shortwave oscillator. Don't make the mistake. This is where I want to go. Ah, there's the peak anyway. And there it's going down again as I turn it. I don't know. Okay, just ignore what it's doing. Antenna. Oh yeah, so on the back here, I've written all that stuff. Shortwave is this one. Okay, the meter. Right on the money. That'd be that. And we go up to 1500 and we do trimmers on gang. RF trimmers on gang. So RF means the intermediate and the antenna. And does it mean 4 of them or 2 of them? There's no other time where it suggests you do them. You do them all. Do them all. That's the thing. Okay. 1500. I gotta move the camera. Got pretty quiet. Did I say 1500? That's not right. 9.6 is what I'm after. RF trimmers on coil unit. Which I think they're talking about these. The 2 underneath here. On coil unit. Yeah, that would be the coil unit. Okay, 9.6 is where we want to tune the radio. Not much further right there. 9.6. The radio's quiet as can be. The 2 trimmers they're talking about, this is the coil unit. There's a trimmer there and a trimmer there. It doesn't specify one first, then the other. 9.6 coil unit. Gotta bring the signal up there too, Jim. 9.6. Right. The frequency is way off here. So when we were supposed to be adjusting this, it was oscillator trimmer on gang. And I tried doing that and I couldn't get it to come down all the way. The other screw didn't seem to do anything. Let's fiddle with it some more. I'm feeling a little more sure of myself. That surely is a mistake. So this is the oscillator section here. These guys must be part of the picture too. A little bit. The trimmers. This one I cranked down, I believe. Yep. This one is. I don't think I touched this one. Very good. So we want to tune in. We want to find out where we are here. Hang on a second here. That's where we are. Heterodyne that's in there, but let's just keep going again. I still have capacitors to change, right? Okay. It's 9.5, or it should be 9.6. Let's try moving it. right at the edge of it now. Whoop. Can't use these. See it snap right by? Spend all day doing that. Need the stiff. Going to tune a little bit off this on the assumption that that heterodyne is coming from another signal. I will tune it back in. Yeah, there's nothing there now. Okay, so what did I manage to do? So I managed to fix the oscillator a little bit. Let's come back to the lower frequency here. And you can just tell the alignment is coming in as it goes down, I would say. It seems really hot down at this end of the band. Let's go back to 6. 6 and okay, we're tuned to 6. Well, that's really close. Okay, now that one we are doing core of the oscillator coil. We're on the shortwave band. Core of the oscillator coil. Okay, sort of like that. That's nice. Go up to the other end. .6. Well, I hope I got those marks right. And 9.6. So that's 9.6 with the same output level as I was just using at the lower end. See, there's just nothing there. It's way off. I thought I got it all the way up to 9.6 there. Didn't I? Didn't I? The radio's tuned to 9.6. So on this band, it's when you adjust the oscillator trimmer on the up here. That's why this goes first. So this is really important to get right. I don't know, can you even get it right in such an old radio? Okay, come in. Okay, and the other one. The side one, the side tuner. This will mean the broadcast There's no antenna. That's my signal generator as an antenna. Oh, I love this radio. Check it out. This is at, what's this at 9.2? Well, 9.6, yeah. I think there's a real strong station just down here. Not bad though. No. So no antenna. What happens if I put an antenna on this? Well, just... Why so quiet? It's just possible it's quiet because my antenna is quiet. Well, the antenna, there's no antenna. There's no antenna! Get an antenna on it, then we'll see. Okay, I gotta go get my antenna set up here. Okay, so many videos ago, before Christmas, you might have heard me lament about squirrels eating all of our Christmas lights, our outdoor Christmas lights, all of them, every bulb, eaten off the string of lights. That'd be like 100 of them or something like that, maybe 70 of them, eaten and gone, and I'm finding them now buried in my yard. Well, they didn't stop just at our Christmas lights, they also ate my antenna leads. So just yesterday I repaired one of the antennas. I didn't even realize it, how badly it had been damaged. So that's what this is hooked up to. This is hooked up to my newly repaired outdoor folded dipole antenna. What's going to happen here? Don't get too excited now. Okay. Off with the signal generator. We're going to try it with the ground connection made. What do we get with this? Nothing. Nothing. Come on. Signal generator. Could be because I have the ground on here. Let's take this off. Okay, not sure what to do. Let's leave it on for now. Hunt around, see what we get. What do we get? It's the wrong time of day for this band, except near the higher frequencies. I shouldn't really get anything down here. Okay, but could start getting stuff. It's either, that's Spanish. It's either Cuba or the American government through Radio Marti. So the way this is, there's a broadcast band here, here, and here. So in this area we shouldn't hear anything. Oh. Unfortunately, even a piece of music like that will be copyrighted. So there's a good chance I'm on my way to getting a hit. So it's not a big deal, by the way. It's simply trim out the copyrighted material, but it's a hassle, right? It takes time to do it. Where to go? Did I bump this?
Por la radio de WTC en 9330 kHz en la banda de
I tried the tone control.
Radio World Jet, preparando un pueblo para el...
Huh? Got cut off there at the end. Lower tone? What? Did it just go off the air? I think it just went off the air. Is it top of the hour? It is top of the hour, all right. So that guy just disappeared off the air. Might come back. Sounds like there's still a carrier there. Nope, he's gone. Who else is here now? We've lost our... Not too likely to get anything further down this time of day. Okay, but the great thing is, it received something. That's great. So, carrying on now. Can we carry on now? Am I carrying on, or am I just looping around? I'm going to leave out the broadcast band. I'm not too concerned about it, frankly, on this radio. I'm never going to listen to AM radio on this. This is not the guy for doing that. Okay, so we should probably repeat this. Cores of the RF coils. 6 megahertz. Cores of the, so 6 megahertz, and we do the coils. 6 megahertz. Okay, back we go. That looks like 6. Let's just make sure. See, there's a bit of parallax there. Okay. Yeah, there's enough parallax there that I probably can't repeat this very well. So we're on 6. Signal generator not connected. Sensitivity is very, very good. Well, that sure looks like 6 to me. Okay, now RF. Where'd he go? Here he is. There he is. Shortwave. This guy. Cores. Ah. Holy smokes. What happened there? I'm hardly feeding a signal in this radio. I've hardly got the volume turned up. I went wild. Well, that's a really good thing, kinda. I was just blasting this radio to pieces. I can't get this any lower, really. I mean, this is crazy. This is 10 microvolts on the antenna now, if this is calibrated. Is it calibrated? Calibrated now. That is 10 microvolts on the antenna. So it sounds like it's feedback, and you're getting that amplification effect. That, for crying out loud, I just can't think of the name of it again. It's a principle earlier radios were designed on. No, just can't get the word to come out. So what do? I peak this thing up until it's oscillating? Because I'm pretty sure that's what that heterodyne is too. Okay, let's do that. Let's just go for the max. Oh my gosh, this is a really, really sensitive radio. You know, basically, you're hearing a radio signal. You're hearing it poke up through the noise. You know, once you can hear the noise, that's pretty much the end of it. I mean, it doesn't much matter how much more sensitive you make the radio, because the signal-to-noise ratio is just going to be the same. So once you can hear the noise, with the volume not up too high, I think you're kind of there. And the next thing is trimmers. What did I just do? I just made a big mistake, did I? I just made a big mistake. Or did I? Oh my gosh. Oh, what's with me in doing this stuff? We're at 6. I just did cores of the RF. Yeah, I did it right. Now we're going to go to 9.6, and we're going to do the trimmers. On the coil unit, I never got to those. Oh, that might solve the funny oscillation thing here. 9.6. 9.6. Come on, stay put, camera. What's going on? It's bumping up on a wire and getting pushed around. Okay. Sure went quiet again. 9 points, a little more volume. So it's there, it's just much quieter. So again, it just on what I was saying before, the variation in the noise level as you go from one end of the band to the other is, I think, is signaling bad alignment and a variation in the sensitivity of the radio. Okay, so 9.6, and you don't want to look at that, I don't think. You'd rather be looking at this glorious view here. 2 trimmers in the back. Wait, there's one there. Oh, don't touch it. There's one there. But I need the signal generator. Still plenty sensitive. Not as sensitive. Okay, since it's easier to tune the radio. I want to make sure it's tuned right on the signal for this. Sensitivity check with a metal screwdriver. Don't see any sensitivity at all. Doing the right thing here. Trimmers on coil unit 9.6. Okay, we must be in the right spot. I would say we are, yeah. Beautiful. Okay, that's one. I'll do the next one. The volume, it barely, it's hardly turned up at all. It's a 100 microvolt signal on the back. Quiet. Not completely quiet. It's gone a little quieter down at this end now. Is that from these two trimmers? Let's fiddle. Screwdriver. What did I? There, right in front of me. Oh, she just broke into oscillation. I like it. I like it a lot. Well, so what did I manage to do? I managed to do basically one band. So so we're going to skip the broadcast for now anyway. The next one is, the next ones are all quite kind of straightforward. No, they're not. Okay, 21 megahertz we need to tune to. 21 megahertz, next band. Broadcast, shortwave, next band, and 21 on there. 21. It was 21, wasn't it? 13 meter band, 21 megahertz. Where did I write 21? Oh, way up at the top there. Very consistent noise level. 21, that's really 21 megahertz, eh? Wow. Cores of oscillator RF tools, 21 megahertz. Okay, that's good there. 21. I didn't hear it. It should be 21. Let's try 22. No. 23. Let's Try 24. I'm looking for the image. No. Let's brutalize it right. There it is. There's the image. Very weak. 23. It's way off. Okay. Way off. Way off. That's supposed to be 21, not 23. Okay. That's good. Let's see what we can do about that. Cores of oscillator and RF coils. 21 megahertz oscillator. 21 megahertz is a band. We need the band number. Band number 13. 13. So 13 oscillator, trying to get it to 21. Okay, we'll head that way. We'll try to find that. I don't know which way we're going with the slug. In you go. Okay, here we go. Is it this way? It would appear not. Is it this way? It would appear not. Is it any way at all? Oh my. It shouldn't have disappeared. Put the brakes on and something bad's happened. On the 13 megahertz band. 21. And on the 13 meter band. 21 megahertz. Cores of oscillator and RF. Where'd it go? It's right there. Okay, so just on the edge here. Uh-oh. 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 What's the matter here? What's the matter here? Tell me I labeled this wrong. Tell me I labeled it wrong. 1325 broadcast. 1325 broadcast. Well, let's see. We haven't done the 16, 19, or the 25. I could try any one of those and see if there's a mistake. It's just not very likely. Not that one. 19. There. No, it's definitely not that one. Oh! It's this one. Blind. 1325 broadcast. 1325 in broadcast. On the back, not that these necessarily line up in any these sets, don't necessarily follow any kind of pattern. 1325 in broadcast. This is on the back, so if you flip it around, it actually looks like this. 16, 19 shortwave. It's exactly the same as this one. What am I supposed to do? I'm supposed to go, oh, okay, I guess we do the 25 now. First, how wrong am I in what I'm doing? Are we really on the right band? Maybe we're not on the right band. Maybe I booped it up here. Let's go back. Okay, that's broadcast. Shortwave. Where we are. The frequency this is picking up is in the range of that band. it is really hard not to conclude that they just made a mistake in the information here. But that's a really bad mistake. How many people have lost their minds over this kind of mistake? Probably 7. Okay. So we'll try to drive that down to 21 using the 25 meter band adjustment. Now where is it now? Where'd it go? Right there. It's also cranked up. It's quite a high level signal there. Okay, let's go that way. Yep. This way. The long ways. Oh, Laredo just went silent. Really silent. Oh boy, what to think. Slug is going a long ways down into this coil. Oh, that's better. Oh! Okay, something going on here with the image and the maybe this was aligned. Oh, you could just see how if you're turning the wrong screw, you end up aligning it on the image. All kinds of weird things could happen in here. So we're at 22 on our way to 21. Keep going. Now it's gone quiet again, and we're almost at the end of the road, I'm sure. So I notice most of the slugs are positioned close to the top of the piece here, but I've just driven this one way down into the coil. In fact, that's the end of the road there. 21.7. Something's not working out here at all. Let me go back to fooling around with the 13 one. Leave this just where it is. I have to find out what the 13 one does. Okay, I'm in. Doesn't do anything here. So we would guess is the 25 meter band is up here. So let's flip to the 25 meter band. 25 meter band. What frequency is it? 25 meter band is 11. 11 point. Say 11.5. So we'll go to the 25 meter band. That would be yes, that's the next band, 25 meters. So we've gone from the shortwave band to the 25 meter band. Oh, 25 meter band. Why am I thinking it's 13? Oh, they got you jumping around here. So you're going, yeah, 13, 25, 19, 16. That's a weird order. I thought it was like 13, 16, 19, 25. I just figure you're going along in a row, but you're not. So you're jumping in on 13. Jumping in on 13. So what? So that's still 13. Because the next band is the 25 meter band. That's why. 13 is not the next band. 13 is the next band. No, 13. Oh, for crying out loud. 21 megahertz. Jim, you're not even thinking. 21 megahertz is the top band. Not even thinking. Okay, let's back. I really messed this up. Let's back this guy way out where he was, because he was probably in the right spot. Way out here somewhere. Okay, Go to the 13 meter band. We'll find it there. Okay, 13 meter band. Why did I ever mess this up? Well, you know, I'd say first time through, written off to painful education. There we are, still on 21 megahertz. 21 megahertz band. We should get that now. Let's turn this down. Meter band is 1, 2, 3, fourth band in. 1, 2, 3, fourth band in. Shall we fooled with the oscillator here? That shouldn't. Well, let's just give it even more. No. 13 meter band. Why am I getting this all messed up in my head? 13 meter band's at the top of the dial. Why am I stopping here? I think I just can't. I just can't. Let's try now. Now we're gonna get it. There she is. Okay, now we're cooking. We're cooking finally. I got there. See, I'm in the process of making every possible mistake. I'm even making mistakes with the mistakes. Okay, now we're going to zoom this guy up to, let's find that, 13, top of the band, 13, small number, gem, crying out loud. You know, just not thinking at times. We're too busy thinking about other stuff to think about the right thing. Come on, you can go in there. There we go. There it is. So go by. I guess that far. A lot more. Radio went quiet. Oh, I went right by 21. That's why. That's why. 21. Now we go back. Which way's back? So you can kind of tell as the oscillator starts delivering the frequencies that are matching with the other tuned circuits, the noise comes with it. But when the oscillator starts converting frequencies that are out of the tuning range of the rest of the circuits, the noise disappears. Now that's pretty certain to be the image. There's the real guy. So you go up and up in radio frequency, like up on the shortwave bands, like here we're up pretty high. The difficulty with suppressing the image becomes very difficult in a radio like this with a small IF frequency of 455 kilohertz. A better radio on these higher frequencies uses a different intermediate frequency, but then it requires a whole set of circuits and tubes for that, you know. So that won't happen on a little radio like this. So we're pretty much at 21. Let's make it right on the money. Okay, it's foolish in a way. I can't tune the radio that precisely with its own tuning dial. But you know, a good rap on the side of this radio and those slugs will move slightly and it'll detune this radio. Is that true? Okay. How about a light rap on the coil? No, a big rap on the radio. Watch the meter. This is not exactly the best thing to hit it with. You know what I got for this? Oh. Yeah. You ready, radio? We're doing the whack test. I will deliver one shock into it. We will watch that meter. My hands affecting it. My waving hands affecting it. There we go. Holy smokes. Okay, like, you know, how many things did I just knock out of whack there? Oh my gosh. They just detuned every band, everything. Well, you know, it's a lesson, right? Or did I bend the radio? I hit it with too hard of us. Hey, we'll whack it back the other way. Yeah. It's a new technique for aligning radios. There. You know, I may have distorted the frame and then distorted it back. Who knows? But yeah, what's all this precision about in here? They make it all nice and beautiful, then clunk it back into its cabinet, and that's the end of all that. Okay, too much excitement here. So, is this still on 21? Amazingly enough, I whacked it right back into tune. Oh my. That should be a standard testing thing. I mean, at some point in the process of testing a radio, you should whack it with a hammer and see what happens. Right at the very end, when you got everything all done. Whack! Okay, can I settle down? 21's done. Oh, cores of oscillator and the RF coil. Okay, RF coil on 13. 13 is here. Watching the meter. Pretty happy where it was. Let's say RF coils telling me to do the ones back here too. 13. Okay, antenna 13. This is the antenna trimmer. I kind of think you really need to do these when it's hooked up to its permanent antenna. You can hear me bopping all. There we are. I think I'm on it now. Something funny back here. That's down. Slug's a little loose. That's the spot right there. Bingo. So exciting. I can't wait to do the next band because of the wonderful mistakes that are coming. 25 meter band. That is worth checking its position on the scheme of things here. 25 meter band would be 1, 2, third band in. Third band in. 1, 2, third band in, 25. Now this one I whacked out pretty bad before. 11.8 megahertz, cores of oscillator, and RF coils. Oh, I got the whole thing figured out now. It's great. 25, so 11.8. 11.8 roughly. 11.8 on the radio. Oh man, how long have I been in here? So these next ones are done roughly in the middle of the band. You can see 11.8 there. It's really tough writing in that spot. Okay, that would look like 11.8. Turn the radio up a little bit. find out now. 11.8. How about 12.1? 12.1, a weak signal can't be the image. So we gotta back this guy down. Okay, let's try to find that. 25 oscillator. I'm familiar with this one. Oh, look at that. Oscillator and RF coils. 25 RF coil. I think I'm in there. And 25 on the antenna. So the antenna adjustments are done from the back of the radio, and I think that's not by accident. I think that's because when you hook it up to your permanent antenna, you really should go through those again. I think. You really want to get super maximum. That's the end of that. The next band is 19 meter band. As I'm no longer using brain power, just eyeball power. That's the next one over. So that's 4 bands in. 4 bands in. 4 bands in. 1, 2, 3, 4 bands in. This is done at 19 meter band, so we're at the 15.3 megacycles. About there. And then we need to set the tuning. 15.3 is up here. 15. Okay, not hearing much. Oh, the radio was turned right down. Sounds good. So this should be 15.3. Close. 15.1. That away. Let's find it now on the 19 meter band. 19 meter bands here. Oscillator. Okay, find that guy. We really want this to be 15.3. So the radio's AVC is making this a little tricky because at first the radio's sensitivity is a little high. So as I adjust it, fresh frequency kind of coming through, then the AVC catches up with it and knocks it back. And what this does is it makes the meter do this a lot. All those whip ups are when the AVC hasn't caught up yet, when you make adjustments. So it's yeah. Am I babbling? Yeah, I'm babbling. And 2 coils. 19. So I was just watching a little TV there a moment ago, and they're showing the Japanese high-speed train system and one of the safety practices, and I saw 2 or 3 guys do this. and they're holding a list, a checklist, they, even if they're alone, they state the value out loud and they point at the instrument involved. So they'll go 600 kilohertz, they'll go like that, and that's their procedure. But somehow this pointing thing is really important. Never heard of that as a factor. Okay, so what am I doing? I'm trying to get this to 15.3. That's where that is. That's where this is. We're done. Are we done here? Didn't I do this? Ooh, there's not much of a peak on this one. No, that's definitely it though. There we are. And then RF coil at the back, 19. It's this one. You know, I've got a signal. Well, I've got an antenna simulator running here. Maybe that makes this adjustment okay. There we go. We're now really moving along, but there's only one more band to do. 16. 16 must be just before the top band. 16 has to be there. So I'm doubtful of myself. 16 should be here. Should be one more band. No more. Come back one. 16. 16 meter band. Why am I talking out loud? 17.8. 17.4. Okay, it's way off again. Okay, so oscillator on this band is 16. Okay, turn it and find it first. Okay, turning it this way. I'm trying to get to 17.8. Wow, that's a long ways. Very hard to adjust with this little. What happened to it? Okay, trying to get to 17.8. 16. Passed it. Lovely. There we are. Cores of the oscillator and RF coils. 16. Here it is. What are you going to do for me now? It's done the same thing again. The more you work it, it just seems to go down, down, down for reasons I wouldn't know. Why would that be? Not a dramatic peak. Okay, and the last one, 16 on the back. Come on, get in there. Okay, 16 on the back. Oh, not in. There we are. I made it. Made it all the way. Let's see what this radio will do now. Okay, the signal generator off. Gonna leave it on its side. We'll put on the outdoor antenna. Didn't seem to amount to much. Not there. Okay, why am I still hearing the signal generator? Very sensitive radio. The signal generator is just laying over here. Fantastic. Okay, so we're gonna go. We'll start with the highest frequency band. This guy. What time is it? It's 10. It's 11. It's a quarter to 11 in the morning. We might get some stuff here. Let's see. That's pretty sad. Okay, next band. Still getting the signal generator. Let's take it right out of the picture. It's suggesting my antenna's crap. Because had something there.
Fue la del vapor Dauntless, el 30 de 1996, después de llevar armas y hombres, un grandísimo cargamento de armas, a Cuba,
Cuba.
El vapor también llevó expediciones a Cuba.
This band's a little quieter.
Yeah, it's that level of faith. That level of faith is a gift. It's got to be because we can't spontaneously generate it within ourselves.
No, only Yahushua's faith, which has been tried to the uttermost, is strong enough to get us through.
And we're going to need it, Dave. When you're told that you can't buy or sell unless you submit to receiving the mark of the beast, It's going to take the faith of Yahushua faithful.
The last two settings are for phono, I believe.
To stand firm for the truth when it means the loss of your job, the loss of your marriage, the loss of your reputation.
So a slight increase in the treble on each of these from here up.
Ridiculed, but yeah, even at the loss of our reputations, at the loss of everything, and even
One
if
more.
we give up everything, and we will have to give up everything.
Okay, well that's great. I'm gonna think about this now. Maybe it's time to bring the other radio in here for comparison. And I'm gonna go through this crazy alignment process with the other radio too to make sure it's right on the money. And then we'll compare these two very, very similar radios and see how they compare. Great, that's a really tough slug. Might be good to go through the whole alignment again, but I'm not going to do it on video. I'm not going to do it now. Now I'm going to go do other things. So thanks a lot for watching. It's a very fiddly and painful sort of thing, but I think I got through it. And great. Thanks a lot for watching.